Everybody. We ready to start again? All right, so let's sit back down, get ready for Express. Actually, the first thing we're going to do is watch a video. This video is not necessarily part of the lecture, but I feel like having a basic understanding of the internet is important before we talk about the web. And there's a distinction, and it's not such a complicated one, but in the modern world, we tend to just use them interchangeably. So the very first thing, let's watch this 5-minute video, which is the best explanation of the internet I've ever seen, because it makes it seem straightforward.
So how does the internet work? Most of us
Good
know
question.
how to use the internet without actually understanding how it works. Sort of like electricity in your home. You use it every day, but may not understand the mechanics behind it. And if the electric grid is difficult to understand, then the internet must be impossible, right? Wrong. In the next few minutes, I'll put you in the top 10% of people who understand how the internet actually works. For SecurityCatalyst.com, I'm Aaron Titus. Whenever most people think of the internet, this is what comes to mind. The internet is not a bubble cloud, even in the new age of cloud computing. The whole fuzzy cloud picture was created by people more concerned about job security than education. This is the internet. The internet is a wire, actually buried in the ground. It might be fiber optics, copper, or occasionally beamed to satellites or through cell phone networks. But the internet is simply a wire.
I want to stop to back him up on that. I like that explanation so much because that is literally it. If you just accept that the infrastructure of the internet is working, it's a wire. You might be connecting wirelessly in some fashion, but it's just the ability for everyone to connect to the same thing. I remember The Daily Show years ago would make fun of some senator for saying, like, you know, it's a series of tubes, and they're like, haha, you don't know what the internet is. He's right. It is. Like, it literally is. There are cables going across the Atlantic because that's how information has to travel on some medium, and generally you wrap it in something so it doesn't get eaten by a shark or something. I guess that's why they do it.
So it actually goes along the bottom of the
Yeah,
ocean?
yeah. There's massive cables at the bottom of the Atlantic that have fiber optics and are as straight as they can be, so you can just shoot a beam across really fast, because that's the fastest way to get internet, to get like any message that is coming from America over to Europe. But it's an understood thing that there are, at this point, hubs for the like there are places where many messages are passing through, and you'd only have to sever a handful of wires at the bottom of the ocean to disconnect Europe from America in terms of the internet. Well, not really, because America could still communicate to someone else, and then they could communicate to Europe. But that's the nice thing about the internet, right? Not just one wire, many.
The internet is useful because two computers connected directly to this wire can communicate. A server is a special computer connected directly to the internet, and web pages or files on that server's hard drive. Every server has a unique Internet Protocol address, or IP address. Just like a postal address, IP addresses help computers find each other. But since 72.14.205.100, it doesn't exactly roll off the tongue, we also give them names like Google.com, Facebook.com, or SecurityCatalyst.com. So this is how it works. Your computer at home is not a server because it's not connected directly to the internet. Computers you and I...
I'll stop them there to say this. Your computer could be a server. Generally speaking, you won't make it a dedicated server, but any computer can be a server. It's just they do make certain computers where what they're especially good at is receiving many requests and sending out responses. Yes?
So, like, if you were running, like, a Tor node or something, would that mean your computer is a server?
I think so. I mean, the fact that someone can hit your IP address and then you can serve something up to them, you still need to interact with an ISP. You don't have a direct connection to this wire, but you are a server.
use every day are called clients because they're connected indirectly to the internet through an
So
internet service provider.
Verizon does have like a more direct connection to these wires, which are guarded naturally.
Now let's pretend that I want to visit AOL.com, which is coincidentally both a server and an ISP. I hop onto my laptop with the SL, go through my ISP, onto the internet, and look at AOL.com.
Yeah, so that wrapping thing is pretty important. You never do it explicitly, but when you send a message, your IP address is included. And every time your computer ends up on another computer in the middle, and you don't know how many computers are going to be between you and wherever it's ending up, and they can look at it, they can modify it, but at each step, they're adding their address. And you just keep doing that. It's like a stack. So the first address, second address, third address, fourth address, it finally gets where it is, but they receive it that way so they can say, okay, I need to send it back here, pop that off, send it to them. Then they receive, like, the entire chain of where it came from is received so that they can then send it back. It's just like a letter where you have a return address, but imagine that you sent a letter to someone and they sent a letter to someone, so you have like a list of return addresses. Yeah, exactly. I mean, and that's ultimately what it's for. It's the ability to say, like, we can identify a unique computer every step of the way to know who they received it from, etc. The truth is, you can modify this stuff, so it's not perfect. But if you're like over HTTPS, I think you have a guarantee that if it says it came along this chain, then it did.
And that's how the internet works, in 5 minutes or less. And you're now easily in the top 10% of people who understand the basics of the internet.
Woo.
If you found this video helpful, check out
Nope.
securitycampus.com for all kinds of ideas.
Nope. I don't know what that is. Yeah, so that is the internet is fundamentally the network. So we could say the internet or a internet, but the power of a shared network is that it's good if everyone's on it. And the internet is just a protocol so that many, many computers can talk to each other. They can find each other through these IP addresses. They can like maintain a chain of where they came from so they can find their way back. And most importantly, the aspect you never have to think of is, well, when you're sending something, it might get there, it might not. And the internet is this layer on top where you never have to think about packets being lost. Instead, you communicate with some like higher level language about how you want to send your data and what you do when you receive it, but you never have to think about something failing and trying again. Like there's lots of electrical engineering things about like signal versus noise and the fact that information can be lost, and I don't know how, but it was some like very important thing in computer science that it turns out you can do networking where you can more or less guarantee if you say like the message is complete, and basically you could say the message is complete and it arrived in order, and even though I got it in pieces and I maybe got them out of order, I put it back in order, this is how it was sent, and you have a guarantee of that, and now go do something with it. And that's the abstraction you don't have to think about. There's obviously many more between that and you. So what's the next one? The next one is the web. So do we have it's going to come up. I'll stick to, that's why, because I just jumped into the middle somehow. Yeah, so that's the internet. The internet is the wires, this box. Have you ever seen this? It's a good show. The IT crowd? You're going to like it. Okay, and the internet is a common channel of communication, but communication doesn't work unless we're all speaking the same language. And we already know at this point that computers don't all speak the same language. At this point, if you both have a MacBook, they probably are speaking a very similar language. They have the same processor. But two computers don't know anything about each other. And when they communicate, that's kind of hard because you have to agree upon what meaning things have. So there's this idea of protocols that someone defines, this is exactly how you're supposed to format something if you want it to be seen as HTTP. You can send it over the same wires of the internet. So any one of these formats you can send over the internet, and it's some way of representing that data you're trying to send that is useful for you and useful for the other person, and probably sends it in some efficient fashion. So which one of these do we seem familiar? I see HTTP. I mean, I'll just say right now, that is the one we will be focusing on the most. Hypertext transfer protocol. And yeah, exactly what it is. So when we send over web pages, even though we do have CSS and JavaScript, we think of that as being a single HTML file. And it is because your JavaScript, your CSS, they end up being HTML tags, link tags, or script tags. But HTTP is the format that says, here is how you send a web page, and here is how you receive a web page. And the person serving up a website needs to understand HTTP, and the person who is creating a browser needs to also understand HTTP, because at both ends, this needs to be interpreted. Just want to see, what other ones do we have here? We have BitTorrent. BitTorrent makes it especially easy to download the file not from one person, but from many people at a time. It's apparently a fun challenge to try and re-implement BitTorrent yourself. You can do it. It's not impossible. Like, it's the smallest of these. SMTP, POP, those are both email things. SSH is Secure Shell Handler, which means that you can like be on one computer and be trying to access the shell of another computer that's far away, but you can access it using this keyboard, and you'll be making changes on that computer. And if someone's going to get access to your computer, you want to make sure it is secure, and so it is very important that SSH is secure, and that Heartbleed thing I mentioned earlier was a bug in OpenSSH, and that was the big problem, that the thing that is supposed to be secure that lets someone control your computer was not perfectly secure. FTP is File Transfer Protocol. IMAP is another email thing. SSL is Secure Socket Layer, so that is when two clients speak to each other. And these are all just different ways of, different formats, almost like a JSON file. It's a specification of what you want to provide to say, this is my message, and this is how I want you to send it, and this is who I want you to send it to. So it's the format that you have to send a letter if you want it to be received in this post office system. And we predominantly focus on HTTP because that is the web. So the web is just the part of the internet that deals with web pages and maybe file transfer protocol. But that's usually traditionally what we would call the web. So yeah, here is an assembly line, and it's not altogether all that different. Oh, this is like a mailroom assembly line. Well, it's very similar in that you have some facility where you take your data and your recipient, and you combine those in some fashion to produce a letter that you're going to send. Then that letter, you hand it off to the internet, who's your postman. He handles the whole in-between thing where it eventually arrives at the other door. And then at the other door, they can look at it. They see the information about who sent it. They open it up. They see what's inside. And based on that information, maybe they'll respond to you. Maybe not. All you know is that once you sent it out, you will get back a message whether it was sent out successfully or failed to ever arrive. But other than that, you just send it out, and then it's handled for you that the internet connects to computers. Right, so let's see this. Client, server. If someone could look up what TCP/IP stands for exactly, I would love to know. It's another transfer protocol, I guarantee you. Okay, so right, it's the general sending something over the internet, which we don't have any more specific information, like it's an email or it's this or that. And really the only reason for special ones is that it's going to make sending it over there easier. Somehow, because you know information about what you're sending, you can compress it, or you can do something to make it so what you're sending isn't so large, because the more you're sending, the longer it's going to take, and the more likely some part of it will fail. All right, so we have our client. Our client sends what we traditionally call a request. So they want something from a server. So they say, hey, server, this is me, and this is what I want, and they have to communicate that in some fashion. They send that over. The server is set up in such a way that it's always listening for requests. And the minute it gets a request, it starts producing a response. And it's going to do something with that response, and it knows who sent the request. So this response is purely for whoever sent that request. And that's sort of a nice thing, that when you write a server, you don't need to think about how many people are using your how many people are requesting your website at once. You just know that I received an individual request from this person, and so I need to send a response to that same person. And you send it to the client, and they receive it. And that is fundamentally the loop that happens in the internet. Later, we're going to talk about single-page applications and AJAX. And in that case, you send back a response that has another little letter in it to send them a future request. And you're just keeping that cycle going. But it's still fundamentally this, where the start of it is sending out a request. The end of it is receiving a response. And as I'm sure you've seen, if you try to visit a website when your computer isn't connected to the internet, or maybe that website's down, you'll get some kind of response regardless, which is usually a 404 or something along those lines, which says, well, I never got a response from the person I was expecting, so I just decided to time out because I'm assuming you don't want me to just wait around all day. But it is an important distinction that when you make a request, you have no guarantees whatsoever anyone will respond or that there's even anyone there. But you do have a guarantee that if it's unsuccessful, you will, like the internet part of it will hand that back to you. They'll say, we weren't able to successfully deliver it, or it broke, something happened. We can't tell you that much, but what we can tell you is it didn't work. Or it worked. So right, one request, one response. So what is this protocol? Well, a protocol is a specification. It doesn't tell you sort of how you have to represent it as data as much as it says, we want a text file that lists all these various things, like you want to set a cookie, or you're trying to request this specific file at this specific URL, and you're at this specific IP address. And it's just all of these, a list of things that you either must provide or are optional that will change your request. And then your request gets sent out, received, parsed, that whole thing. So Node has a built-in way of doing this called HTTP. And if you're building something with Node's HTTP library, you have to build this letter. And so here's some things you might have in your HTTP. So the HTTP request is generally split into two categories. You have the headers and the body. And you might recognize that from when you write HTML, and you have the header and the body. So the header is everything that it's metadata. It describes what you're sending, but it's not what you're sending. But it's information like, here's what I'm looking for, and this is my name, and things like that. So what's happening here? We're saying post. So post means, post is I am trying to add something. So we'll see in a bit that there are these different verbs in HTTP that describe what you're trying to accomplish. And it's all, this is what people mean if you've ever heard of the phrase a RESTful web service or something, a RESTful web server. It just means that you use these verbs like post, put, delete, get. There's a few others, and the idea is they specify exactly what you're trying to do, and you have some guarantee that it is what you call an atomic operation. So the problem with being able to receive requests from lots of people at once is, what if you are keeping local variables around, and you set a local variable because you got one request, but then you get another one, and that also needs to access it. And these HTTP verbs are about saying, depending on what kind of request you do, all of the information is going to be contained within the request, and it's not going to have to rely on the state of the server. The server, basically, every time we get a request, we can treat it as if all that matters for fulfilling the request is what is contained within the request, what the type of the request is. So we have a verb here that says, I want to add something. And that tells the person at the other end that, well, there's something inside this letter. I need to open it up. And sometimes there's not something inside the letter. If you're doing a GET request, all you really have to do is send an empty letter with your address. And what you really want is for them to be notified. You want them to put something in and send it back to you. You don't need to include anything in the letter. It's all included in this specification of what you want. Then we have the URI or URL. So there is some small difference between a URI and a URL, but for the most part, you can consider them the same thing. URI means Universal Resource Indicator, and a URL is a Universal Resource Locator. I honestly don't know what the difference is, but what I know is that that's what you're used to seeing as like, the location of a web page, but that's not all it is. What you're saying there is you're defining a specific route that the other side is going to be able to interpret and know exactly what resource you're talking about. So in this case, it would say, whoever I'm sending this message to, you've told me to access it in a way where I say, I'm looking for a doc, so /docs, I want the first one, and then I want this category called related. And at the other end, they're going to have an endpoint that listens for exactly someone posting to this, and if someone posts to this, then they provide whatever data is associated with this request. Here it's saying the version of HTTP. That is something you generally don't have to worry about. HTTP is a standard, and at some points, someone has to send a message out on HTTP that tells the internet HTTP's version has updated. It now works differently. But that's not done all too often, and as a web developer, you never have to think of the fact that HTTP is an evolving standard. The host is who you're trying to send it to. So this is the IP address, ultimately. This is who you are going to be sending this post to, and then asking it how to get access to this information. So sometimes when you send a request, you'll do it like this, but when you type something into Chrome that says like www.google.com/x/y, what you're really doing is saying my host is google.com. My browser is able to take that host name and find out exactly what the IP address is based on that, and then it will build this request for you. So every time you hit enter on your browser, it's really just building a GET request for you, saying get the index /. So if I say www.google.com, that's going to say get / from www.google.com. This accept business, I guess this is one of the many optional things. This is saying something along the lines of, here's what I'm expecting to receive, and if I receive anything else, then I'll be able to give a specific error message saying not just like it didn't work, but rather I wasn't given something of the right format. Stuff about encoding. A user agent is exactly who's operating on your behalf. So that is going to be your browser, and that is your identity as far as the browser and the server you visit is concerned. Important thing to know about user agent. Oh, there we go. Verb, URI. These are all headers. A user agent can be spoofed. So for security purposes, never rely on a user agent because someone can just open up their HTTP and say, oh, I'm actually this person. And it's that easy because when you have direct access to the letter, well, you can cross out a name and write your own name on there. And that's why HTTP is not necessarily secure, and you can use HTTPS if you want all these security features, but it's a lot of extra work if you're a server that has to figure that out yourself. And then finally, we have the body. So this is what's inside the letter. And here we said we're posting something. So we're saying, I want to communicate at this endpoint, but I need to provide you some data because I guess I'm saying I want you to save it. And here is how I provide the data, which is known as a query string. And what you'll see is that we end up encoding these in our URL. So we can write a URL that contains all this information, who it's trying to go to, what the endpoint is, and then finally what the data you're providing inside is. And this will appear at the other end. So they could say, oh, I just received a post request. It's at this endpoint, so I know I have to save something that looks like this. And I'm expecting that that letter will have a book ID and an author so that I can complete the thing and then write back, yes, I successfully did it. Or otherwise write back, sorry, you provided me bad data in a certain way, and hopefully you give a specific error message. So these are the most common verbs. I believe there are other ones, but this is where they're out of order for it. But if you think of the post as being on top of the get, and we read them on the right, we see create, read, update, delete. And that's this acronym you often see, CRUD. So a CRUD app is an app that exists on a front end on the internet, and primarily the way a user interacts with it is they request data, they update specific data, they create new data, and they delete existing data. And that describes most of what you'd want to do with like any database. So lots and lots of apps are what you call a CRUD app, and I would, honestly, most things are. Even something like Netflix. Netflix is really, you have an interface that lets you search their database, and well, the idea is Netflix doesn't let you create movies or update existing ones. They really just let you read, so it's not a CRUD app. But anything where it's like an in-company thing, where different people have different privileges by which they can update this database, but they don't need to, use a shell. They can use this visual interface. You'd consider a CRUD app. There's a question?
This is kind of like the model view controller, like how like when you're moving through something like Twitter, you want to like update your status and then like different parts. I don't know. Is it similar to that?
The model view controller idea, that is a front-end architecture for doing, no, it's not the same. Salesforce is definitely, it's like, Salesforce is like a CRUD as a service. Salesforce is a program that says, you just provide us your database, and we turn it into some program that has an API that lets you access that database. And yeah, I mean, Salesforce is very successful at that because they realize the big problem, like lots of people have data, they understand their data, they just don't want to set up a server and a database and a front end. But as you'll see, it's not too bad. Yeah, and then you'll send back a response. So a response looks a lot like the request, but it has some other information. It'll usually have some information like, the date, the server that sent it. You'll often have something like when it expires. So lots of things use cookies, and a cookie is a way of just sending some additional information that every time you talk to the same server, that same cookie will be sent back and forth. And it's just it's like a shared little box where they can send you something, it stays on your computer, but the next time you talk to them, you send it back. Yeah?
Is that the reason that cookies have to be stored on the client computer? Is that I remember reading something in the pre-reading about how HTTP requires the server to be stateless. So like it's not keeping track of the fact like somebody at your IP address wanted this before, like you.
The server being stateless is what the whole RESTful thing is about. So RESTful stands for, if we look it up, the word state is going to be in there. I don't know how all of you feel, but it makes me crazy that when I have to talk exclusively in these acronyms. So RESTful, what is it? Representational state transfer, which is a fancy way of saying your computer is in one state and it receives a message that tells it exactly how to move from its current state to its new state. Because you want, as when we learn databases, you'll understand a little bit more about this idea of atomicity. But what it says basically is you want to make sure that when you make an update, you know you're starting in a given state, and then you know that you're the only operation that will happen before you enter the next state, and it's only when you enter the next state that someone else can update it. Because what you don't want is multiple people hitting something at the same time. If they both try and modify the same file, and let's say one is successful, or like one changed it, and then they immediately write back, hey, I changed it successfully, but then the other person at the same time overrode it, you think it has a certain value, it doesn't. And it's just a way of making sure that only one person is touching the data at a time, because very bad things can happen when two people access it at the same time. At best, it doesn't equal what you think it does. At worst, it's corrupt data because your request changed half of it, their request changed the other half, and it's not true for either of you. It's just a bunch of random bits. And the body of an HTTP request is always HTML. Even if you don't explicitly write it, it's automatically going to be wrapped for you. That you'll have a basic HTML, a basic body, and then an empty string. But that is what HTTP responds with, and that's always what you're sending back, and it's inside your HTTP or inside your HTML that you reference your JavaScript and your CSS and all that stuff. And then from the browser's end, your browser knows that when it receives HTML, it renders it. And it's kind of an impressive thing that they managed to do this, where like browsers are the ones that can think of how to render this visual component, and HTTP, the thing that you communicate with is this much more simple language by which you specify exactly what you want. And that's all HTML is. It's a very specific specification for what you want to appear on the screen, but the rendering process is handled by the front end, as opposed to you render it on the back end, and then only when it's rendered do you like send over an image or something. Instead, it builds it. Common statuses. So when you write a server, as you'll see, it's your responsibility, whoever writes the server, to choose good statuses, because something can happen successfully, and you can write back to them, 404, it's broken, and Chrome will automatically respond to a 404 and say, it's broken. But these don't have inherent meanings. They're just agreed upon. And if you look on Wikipedia, you'll see there's a lot more than this. There's many for very specific situations. In general, the 200s are good. 300s are not an error, but something along the lines of cached. Something like, well, I didn't go get it because I already had it, so I never sent the request, but I think I have what you want. 400 is bad, something went wrong, there was something bad about the request. 500 is, I don't know what happened, but the person who's supposed to send the response messed up, and I don't actually know exactly how you get 500s back. I guess a 500 is when it's received by the server, but then the server wants to communicate to you that maybe given some data you sent, it can't do anything for you. Like the data you sent, it was bad. And all these are just useful for really web developers on the front end and the back end to communicate back and forth, where you don't have to send a lot of information, you just send this little number that represents something. And you'll see a pattern where like 200 will be the base case. It just means okay. But then 201 says, okay, I successfully created something. Same with 400 means bad. And 401 means bad because you don't have the rights to access this. And 404 means bad because I couldn't find the thing you're talking about. It's a lot of fun if you go on Wikipedia to look at things in the 500s, because there's all of these insane things like the status for, I can't complete that because it's illegal in your country. And like that is very strange to me, but I guess like if you hosted some website and the Chinese government was like, don't show that to China, you could serve up a 504 to let them know like, okay, what you were doing, what you did worked, but China won't allow me to do this, and I'm not going to give it to you. And that's what's in the 500s, those weird cases of, I got the message, but I'm not going to respond to you. So what is Express? Express is a Node library that is built on top of Node's built-in HTTP library, and it makes things a lot smoother because you don't need to specify all your headers. You don't need to be explicit about building up this letter like as an assembly line. You use these tools it gives you to make the whole process of associating an endpoint with a given URL and then, receiving the request and then sending back the response. Express is a great library, and it's great that we're starting with it because it's a library that actually has good documentation, and there's ultimately only so much to learn for Express. It really can be summarized in like 10 functions that you'll use over and over again. Okay, so I'm going to do some code now. Actually, before I do the code, what about this? So this is an image that's expressing like what the current state of our architecture is, and we're going to add to this as we go. So what we started with is stuff we didn't write. So we started with Chrome. We already had that. Chrome understands that when you type something into the URL bar, it does a GET request to whatever IP address that is. And Chrome also knows that when it receives an HTTP request, it's going to look for HTML, and it's going to render that in the DOM. And if it sees any script tags, it's going to execute those script tags in its JavaScript environment. So you didn't have to write any of that. And then over here on the far side is your computer. So let's forget about this node thing for right now. This machine 1 is your computer, and it has an identity. So let's say someone communicated through HTTP over you. Well, what we're calling the file system right now is just, stuff that's on your computer. And so what we're going to be building in Express is this layer that stands between files on your computer and the internet so that you can package them up and send them back to people who are making requests. So we're going to be running a program called Node. And in Node, we are going to be using a library called Express. And so we're expressing that in all of these smaller and smaller boxes of what is inside what. But Express is going to work in this sort of chain way. And you'll see more of it. So Express has this idea of middleware. And middleware is a common thing people say about it is it's a boring name for something very cool. Cool. Maybe not cool, but useful, right? And middleware is this idea of the assembly line. So it says, I'm going to do this first, and then when I'm done with that, I'll call next, and then I do the next thing, and then the next thing. And it's about saying, okay, I received a request. Well, I want to unpack some information about this request before I can then send something back to you, and I want it to go in this order so I can separate my logic. A lot of you took the approach in that last workshop of creating a done function. And Next works the same way, where everything is asynchronous, where it's waiting for some request to happen, and when it happens, it receives stuff and then runs some code. So how does it know to move on to the next step of the middleware? Well, part of Express is that you're given this function called next, and you simply call next whenever it is that you're ready to move on to the next stage. And so this is a pretty common order for middleware. So here's the logger middleware. This says, can I make it bigger? I can. And really what we care about predominantly is this, so that's what we'll look at. So the first thing we do, we get a request. And what do we want to do when we get this request? Well, something useful often is simply to print out, I received a request, and it looks like this, just so that someone using the shell could see that. So that is our logging middleware. So we print something out to the screen. Once we've done that, we hit next. And what does next do after that? Well, in this case, we have what we're calling static middleware. So static middleware means I am serving up a static file. So something that already exists, it's a file, and you provided me a URL to that file, I'm just going to give it right to you. So static middleware is a shortcut for having, so instead of having to create a route that says, when someone does a get on slash serve up index.html, you just say that, that everything in a certain file, that everything in a certain file you're willing to serve up, and if the URL matches the path of that resource, well, then you send it there. It's actually optional. Everything could be done with just gets and puts and deletes, but it's a layer that lets you say, all of these files, I want to put them generally in a folder called public or something, and what you're saying is, these are files that if someone requests them, they can have them. And that's basically it. And index.html is just the special case of it fits the root. So if someone requests your host and then slash, what they're looking for is at the root of your server in index.html. And if someone requests slash settings, it means they're looking for something at slash settings slash index.html. And that's where they're looking for that file. Then there's this thing, body parser. Body parser is middleware you will commonly use. It's kind of the hardest one to explain because really what it's doing is it's taking any data that was sent in your letter and then putting it in a form that makes it easy to access in Express. And it's probably the part of using Express that will be the most copy-paste. I don't really know what that's doing, but it's doing something. And really, to understand it, you get into these niggling details of sort of like why you have to encode things a certain way. And if we do the security lecture we normally do at the end of junior phase, you will learn why we use this as opposed to doing it ourselves. But for the most part, you do it yourself. For the most part, you use this thing body parser because it does it right, and it is like backwards compatible with how old browsers communicate. And then finally, you get to the router. So if what you were doing was not a static file, and so this is a case where, let's say we were trying to send a static file. If that's what they requested, we would end right here, and we'd say like, send it back. And when you send something back, you don't do the rest of this. You just go that way. You sent something back. But what we're doing is saying, like, OK, we logged, and then we're checking if it's static. If it's not static, we go to the next thing. And then this body parser is saying, well, if this is a put or a post request, it's going to have data inside of it. And you want to access that data by saying something like request.body in JavaScript, but by default, that isn't going to happen. So this is an example of a middleware that like you run it because you need to do this before you can do this, because this like sets up how things are going to look. So this is like taking the letter out of the envelope and writing it down in a specific form, so by the time you get to this step, your data looks how you want it to look. And then finally, you hit next, express.router, and this is your routing layer where you're going to have all of your URLs that are not static files, where you say like, I'm listening for someone to communicate with me through any one of these ways, and if it works, then do whatever code is inside that request callback. And that will usually involve sending something back. But if it all fails, what you want is this error handler. And as we'll see in Express, the way the next keyword is used is if you want to move to the next middleware, you apply that function. But if there's a problem, you apply that function, but you include error. And Express knows to jump down to the error handler. So if at any point in any one of these middlewares something happens that you know is like a fatal flaw, well, what you can do is call next, but instead you like provide maybe the status code or something like that, and it will jump from here all the way down to the error handler and then send back a 404 or something like that. And by default, Express writes an error handler for you for 404. And yeah, that is the round trip. So what you send back is ultimately going to have some form of HTML in it, and it will be received here, and you draw something. So what I want to do right now is program a little. Actually, there's this right here. And this is just an example of if I do a GET request of Google, this is what it's sending me back. And like this is the body of the request. But you see how much else there is, where I look at the heading, and this is like all this stuff that they've made explicit, like how they expect Chrome to use my cache, something about like the character set. Yes, sorry about that. XSS protection, so some stuff about security, stuff about setting a cookie. And this is all this like additional information that Chrome wants to communicate with my browser, even though me as a user, I don't directly see it. Let's quickly just start making a server or something, because I think Express is best understood when you're building this stuff explicitly. So how do you make like a really basic server? Well, I'm going to just make a directory here called simple server. And actually, I shouldn't do that because I already have something on my computer called simple server. It's a Node program that someone made, which if you opened it up, what you'd find, it's a really basic server. So I'm going to say my server, go into it, and I want this to be a Node project. So the first thing I'm going to do, because it's a Node project, is do npm init. You haven't necessarily done this yet, but when you do npm init, what you're saying is, well, you're describing what your document is, but most importantly, you now have the ability to ask for dependencies. And in this case, Express is our dependency. So I'm going to say npm init. It's going to ask me some questions, in which I'll just keep clicking enter. It doesn't really matter until you're publishing your package, and you're not going to do that until when you publish it, you're saying, I want other people to use my program, and don't worry about that for right now. It doesn't matter what license you have, or it's not very important until you want to share your stuff. What? It's just a document that keeps track of various things that NPM would want to know about if you ever were to host the code, so that someone else can pull that information. But it also is where you're going to keep track of things. If I say npm install -- save Express, I'm saying install Express. I'll have a local copy for this project, and when I do -- save, I want you to update package.json to reflect that. So it's going to install it. It got it off the internet. And if I open up my package.json right now, and I'll make this a lot bigger, you'll see that it says dependencies express. And that's useful because if I share this code with someone on GitHub, well, I could include all of my dependencies as a folder with all of the code. But why do that when I can just have a file saying, here are my dependencies, and before you run this code, you have to install those dependencies, and you just type npm install, and it will look for this file, and it will look for this list of dependencies, and it will go one by one, downloading that thing, and most importantly, downloading the version of it. Because depending on when this project was made, Express could have been updated, and maybe their project expects to be on 3.3 or something. This caret figure here, I believe what this means is 4.14 or latest. There's different things you can provide if you want to be explicit about it must be this version, or this version, or any newer version, or no version above this version. So there are various things you can provide, but generally by default, if you say npm install -- save, what it's going to give you is the current version and a caret, which means the current version, and if a new version ever comes out, just use that instead. But you can always remove it if you want to be explicit. OK, so now I am going to make my server. And I'm going to say subl server.js. So how do I make a server? Well, I need to use Express, so first I'm going to require Express. And why not call it Express? So I'm going to say var express equals require Express. And then Express is the library, but there's lots of things that are on the Express object. But something interesting about JavaScript is that whatever it provides you can be an object, but it could also be a function. It could be both an object and a function. And you've seen things like this with date, for instance. So if I open up a version of Node here, so I could say something like var d equals new date. And d now has a date in it. And I'll say type of d object. OK, I thought it might have been date. But while date can be used as a constructor function, it's also just a function. I could say date, and that returned me a string. And I could also even do something like date dot, and it's an object. It has a bunch of stuff. So that's a weird quality of everything in JavaScript being an object, that something can be both an object and a function, and, well, just about anything, because they're all objects. So date dot now. And Express is the same way, where Express is the library, and there are times where I'm going to say something like express.static to get something off this Express object. But in fact, if I just take that Express object and I apply it, treat it like a function, well, that's going to return me an instance of Express. And what that means is it's returning me essentially a single server. By and large, you're only ever going to have one instance, but let's say you're running some fancy app in which you want to have 6 different servers running at the same time, you could do that. You would just say var app2 equals express again. And that's going to be a brand new server that will listen on a different port or something like that. All right, so we created this app thing, and what app returns us has a bunch of functions in there, but it has this thing called listen. And listen is how you're going to interact with the rest of the world. So, yeah. No. So that is an interesting thing about JavaScript. The new keyword is used in JavaScript, and all it does is it says, if this function, so when you use the new keyword, you're saying whatever function I'm about to create, well, I'm going to create a new this variable. That this variable can be updated by that function, and then it is implicitly returned by that function. This guy, Rich Hickey, who I believe invented Lisp, whined a lot about how the new keyword isn't necessary in JavaScript and we should get rid of it, and we should only use object.create. And the idea is any function in JavaScript can return a new object. So if I have a function create, I can just say return, some object. And the idea is the new keyword is used to create a new object, but any function can create an object. I admit that it's a little strange that you have a bunch of ways of doing the same thing, but if JavaScript has one quality as language, it's that it is insanely flexible. If something could theoretically be thought of as useful, it's probably possible. Right, so we just call express as a function, and then I'm going to do app.listen, and .listen naturally is asynchronous. So it's going to wait for some event, and when that event happens, it's going to respond. So what does app.listen take? And this is probably a good time to look at, see, I have it right here. This is a good time to look at the Express docs, because the Express docs are actually good. So Express docs, Express 4.x. Yeah, and you'll see over here, so like what are things we commonly use? We use express.router, we use express.static. Those are both things right on Express, so we also use Express itself. And this is it telling us here, and you'll see this all the time. It's very common to just call it app. People will just use these patterns over and over. And then finally, well, we'll get to some of this stuff. I'll start with Express, and the next thing I want to do is maybe serve up a static file. And sorry, before I do that, I want to listen, because what's the point if I'm not listening? So I see Express here creates an app. It creates an Express application, and I'm going to click Application to learn what that is. So that's what app is holding. And I could just say app.listen 3000, but usually there's some sort of callback in which you say, once I start listening, this is what to do. So app.listen, I'm going to give it a port number. And a port number is just a unique identifier for your computer to say when I receive something over my hardware. So if I receive something over the internet, how do I know that your program wants to look at it, not some other program? Well, it's because every program has registered some number that they say is uniquely them. And if you're listening for that port, well, anyone that communicates over that port means they're not just speaking to your computer, they're speaking to your computer specifically to that program on your computer. So if our host is google.com, and we wanted to speak directly to this single port on google.com 3000, we would say google.com:3000. Honestly, don't listen to that. We'll see it for how we do it for ourselves. But I'm going to write a callback here to say, when I get a request, just do something. So console.log ping. And so every time we get a request on port 3000, so we start our server, we listen on 3000, and we say ping every time it happens. Although we're not responding in this case. We're just writing ping. Okay, so that's my server. And let me run my server. Okay, so node, let me go into my server, cd my server, and I'm going to say node server.js. So it's a program like any other program. Yep.
Where is the server running in my computer?
Yes. So it's definitely something that gets a little confusing when you're developing, that there will be this front-end world, and then there's also the back-end world, and oftentimes you're testing both on the same computer. But right now we're dealing with back-end, and it's running on your computer, and the idea is you're expecting a request to come in, and then you have access to all the resources on your own computer, and you're going to build this response and send it back. So I'm going to run node server.js, and you'll notice it said ping, but it didn't say anything else. I'm actually realizing it doesn't say ping every time it gets something. It's only going to say ping when it starts. So this callback is actually for the server started. So this is like the last thing that happens. The server started. Let me just check time. Are we going to 5? No, we have 15 more minutes. So app.listen is going to listen on this port and then say server started. And from that point on, everything is hooked up. So let's try that one more time. Node server.js, the server started. I can type, nothing's happening here though. You'll notice that my server, like the program didn't end, because what app.listen actually does is it sets up this server, and that server just perpetually listens. And a server is a program that you want it to run forever. So the idea is it's always going to be responding to requests, but it never actually ends. It's always going to be listening for a new request. So what kind of requests can we listen to? Well, the first thing I want to do is create some kind of logger. So how am I going to create logging? I'm going to say something like app.use, and then I'll call it my logging middleware. And I'm going to make that a separate function. So you don't always have to, separate it out, but I'm going to make this function an explicit separate thing. But app.use means that whatever I'm providing here is a function that's going to have a certain format, and that is going to be middleware, so it's going to run on any route that it matches. So what route will it match? Well, there's actually an optional first argument. So if I don't provide a first argument, what I'm actually doing is I'm saying match on slash. And what that means is match on slash, match on slash XYZ, match on everything. So what you're saying is this middleware runs no matter what, because it matches on the root, and every request you get will match on the root and then maybe more specifically. But when we're dealing with middleware, this route matching is general. We want it to match on as many things as possible. So my logging middleware, what is that going to look like? Well, Express actually will do different things depending on how many arguments that our function has. And the names of the arguments don't matter, but the order of them does, and the amount of them does. And you'll get into that a little bit more in the workshop, but you'll see the same patterns over and over where people name things in a certain order that makes it simple. So what do we get? Well, our first argument is our request. So that's a single object that's going to live throughout the life of our entire Express app and represent this request object that we received. Then there is response. Response is another object that's going to represent the response that you're going to continue building up and then eventually send out. And an important thing to note is that the request and response that is being provided to your middleware, if you have one middleware run and it alters something on the request object, the next level of middleware will see that change. So there's only a single request and a single response object in the entire Express app at any given time, and you can modify it in one level of middleware in preparation for how you want it to look in the next level of middleware. So the idea is like I might add something to my response in the logging stage, but it's only in the routing stage that I finally send it. And then finally, we have next. And this is the trifecta for how you make one of these endpoint functions in Express. So next is that function that if I call it like this, I mean move on to the next state of middleware. And if I call it like this, I'm saying move on to some error logging middleware. And when you get an error, like you can use this information for your error middleware. So this is some logging middleware. And the order that you create these app.uses does matter. Because if I created some app.use above this, it would supersede it. That's what would happen first. So when I add this first, I'm saying I'm doing logging first. This app.listen can happen anywhere because it's async. So the idea is that's just attaching this function that will run whenever the 3000 is, whenever you communicate over port 3000. But the Express stuff in the middle, the order of it does matter. So what am I going to do with this request? Well, the first thing I want to do is say console.log request. And because I'm done after that, I'm going to say next. And it's going to give me some errors because I'm not sending back a response. But this should work for our basic purposes of seeing that we logged out our request object. OK, so no daemon is pretty useful when dealing with something like this because we're going to be reloading all the time. So I'm creating this server. And the server is started. But how do I interact with it? So one way of interacting with it would be to open up a browser. And if I hold down Alt and I click my Wi-Fi, my computer will tell me my actual IP address right now, 192.168.6.76. But when you know you're dealing with your own IP address, and the only time you're doing that is for development, but it can be useful at times to just have a shorthand for this, and there is one, and it's called localhost. So if I type in localhost, it's sending out so my browser will send a GET request, but who is it sending it to? It's sending it to myself. So I don't even know if it ever leaves my computer, but if it does, it only hits that router, and it says like, you're right here, and it sends it back to me. But for development purposes, it can be very useful to be able to mimic this, send a letter, but to yourself. So I hit localhost. The site can't be reached. Why not? Well, I actually need to provide a port, which is why I say :3000. And now, saying cannot get / So it's saying that it tried to make a request to this IP address, localhost, on this port 3000. And even though I didn't write it explicitly or implicitly, it does a / there, which is, it's asking for the root thing at this location. But I actually didn't write a handler for that. So if I look in my error log, if I look in my logging, I printed out all of this information, far too much information. So what do I actually want to do here? I know that there's better things in the request object. So let me go back to the Express docs. I'll make this bigger. Well, I guess I have to make it like I want to see this. So what does my request object have? Well, it's got lots of stuff, but among other things, it has original URL. It has path. What do I want? Well, let's say I care about the method, and I care about just the path. So I don't care about params. I care about the path. And as you'll see here, the node's request object already has some built-in built-in variables to make it easy to get exactly what you care about. So if I only care about the method, I say request.method, and it will get me get, post, put, etc. If I care about just the URL, I could say rec.path, and that's going to not provide me my host, because I already know that. It's going to provide me everything after the / but not including like this query string, which is like additional information. And if I want the query string stuff, I say something like rec.params. The name of that query string. Well, not exactly. You have to add a little bit more before we can do that. But as you see, there's So rec.query will give me access to an object that has this various stuff. So Q actually looks like something. Okay, but I care about my rec.method and my rec.path. So let me print those out in my error handling middleware. So I'm going to say, here's my logging middleware. You know what? I kind of think this is ugly. I'm just going to put it. Directly in there. We can do that in JavaScript. So instead of calling it like that, I'll just do this. I'm not going to give my function a name. I just put it here. Like, it's a callback function. It's a function that expects a function as an argument. And so instead of printing out the whole request object, I'll say something like this: console.log request.method plus space, or just comma is the equivalent of adding a space between the two arguments, rec.path. So I'll say something like request. And this is the request. So I'm going to save this and let me have these side by side. So here is where my server is, and here is where I'm going to make my request, because even though my server is running, I still need to make this new request every time. So I'm requesting to 3000. Still can't get anything because I haven't written a response, but it does know get slash. And if I say slash, it knows about that. And there's even more things. So like I downloaded this program that you'll also have access to. We talked about it in the workshop, called Postman. And Postman is a nice program for sending fake email, sending fake HTTP, like saying exactly what you want your request to look like, because you want to test it out and you don't necessarily want to open up a browser, or you don't want to use curl, which can do everything this can do. Curl is a command line thing for sending HTTP requests, but it is very annoying to use, and don't use it if you don't have to, is what I would say. But yes, this is a GET request to google.com. So what if I said I wanted to do a post request to localhost port 3000 and this slash, I'll say article /1. So I'll send that. And it received it. So I got a post request with /article/1. But these are just requests. We need to make a response. And in the next 5 minutes, that's exactly what we're going to do. So what do I want to do here? Well, something really, really basic. This app.use is going to happen no matter what. Like this will always happen. It'll match anything on slash. And then we call next. And the next thing we're going to write is not middleware. It's called a endpoint, is what I would call it. But it's these helper functions that are provided for you on app that match these various HTTP verbs. So what I say is something like app.get. The first argument is maybe slash. And the next argument is one of these functions that takes rec, res, and next. And you don't have to provide next if you're not using it. But really the only reason to not have next is if what I'm planning on doing in this is sending a response, and there's no way there's going to be any sort of error. So I do get slash, and this will match on a get request to slash. So an important thing to note that unlike here where the slash means match on slash and anything else that starts with slash, when I say get, I'm saying match on slash and only slash. This matches exactly slash. So when I later say something else, like I'll make another one, app.get slash article, I'll just say articles. Well, this is not going to match on slash. So instead, if I do slash articles, first it will run this. It will console.log that. Then it will check if it matches this. It doesn't. Then it will check if it matches this, and it does, so that code will run. But yeah, let's write them one at a time. So how do I send a response? Well, I can say res.send, and I can send whatever I want. So I'm going to send, this is technically enough. Okay, and let's try that out. So once again, here's my server, and here is where I'm going to be doing my GET requests. And what happens when I do a GET slash? So it heard it, it sent back a response, and what was that response? Well, it was this very basic HTTP where it just took my string and wrapped it up into an HTML with an empty head and a minimal body. I'm actually not sure if it's Express that does that wrapping or if it's Chrome. But one way or another, it's just worth noting that the only thing that could ever be received at the other end of response is HTML. And all your browser knows how to do is just start running that HTML line by line where, you know, if it sees body or like a div or a paragraph, it prints it on the screen. If it sees a script tag, it starts running that script, etc. And that's ultimately how you're going to send over everything. And anything else you do is ultimately a helper, but what you send back ultimately is just HTML. And maybe you've set some headers to make it more interesting. So I'm not sure if I can do anything interesting about like making it so that if I set a different status than 200, Chrome will do anything with it. I'm trying to see how I would actually tell. So if I do timeline, I need to capture it on the network. I'm going to reload this. Okay, what's going on here? I'm doing this just to find out. So you can see there's a lot that goes on that luckily you don't have to think about. I'm trying to just see what response I got. The fact that the response is 200. Is it network? Yeah, there we go. Oh, so this is pretty interesting. The first time I did it, I probably got a response of 200. This time, I got a response of not modified. So somehow, probably through Chrome cached this file, and it decided that because I had accessed that file so recently, it wasn't going to make another request. It was going to assume that file hadn't changed and just serve up the same one. But now if I make a new one, it should be a 200. So I'm going to say app.get/articles, and let's just imagine I have this thing called articles. Var articles equals a, you know, these like really short articles, because I don't want to write that much more. So write articles. I can just send back all of the articles. And in this case, articles is an object. So what I might want to do is something like, I might want to send it back as JSON. So I'm actually saying I want whoever receives it to receive a JSON object. In this case, actually, I don't want to get into that right now because that brings us to, you know what, let's just see what happens. If I say res.json and I provide it some sort of object, what happens? So now I'm going to do articles. So /articles. You'll see it was a 200 this time because it's brand new. And yeah, what it did was it took that object, it encoded it as JSON. And all a JSON is a way of encoding JavaScript as a string, or a way of encoding JavaScript objects as a string so that you can serialize them. What that means is that you're representing them in some fashion where they can be sent in chunks. And in this case, when you take an object and you turn it into a string, well, it can be sent one letter at a time. And then at the other end, it can be put back together and then turned back into a JavaScript object. And there are times where you're going to want to send back data as opposed to HTML. But in this case, because I did it from here, what it actually returned was, you know, a string, and it simply put it as a string inside of the body. What else to show here? Oh, right. Well, what if I wanted to do something like send back a 404? So that's a good example of where I might write my error middleware. So error middleware is another app.use, but I'm going to show it at the bottom. And it's at the bottom because it's usually the last one you do to say, well, this only happens, yeah, I'm over. Oh, what is it? The use method. Yes. So use means that what it's expecting this function to be is middleware, which means that whatever you give here, it will match it. What do I want to say? Greedily. It'll match not just slash, but anything that starts with a slash. And if it was slash articles, it wouldn't match slash, but it would match slash article slash one slash article slash two. And that's something that I want to happen, as like a pre-step to whatever my final step is. And in this case, I'm logging something, and then I say next to move on. App.get is different in that, well, first, it only matches exactly the slash. So it's what we call an endpoint, as in there's one of these for every one combination of the verb and the path. So the resource that you're trying to match on and the verb of what you're trying to do with it. So, and the thing about a get is that is where you're going to actually send your response. But the idea is this is basically shorthand for if I said something like app.use slash, make sure it's just a slash, and then look inside the request to make sure that it's a get, and also, that the path is just a slash. And once you verify that, then do this. So these really are just helper functions, and app.use is the primary thing that's going on at the end of the day. All right, so what did I have here? I was sending those back. The final thing I'll do is just make some error handling middleware. And so that's this final thing here. And when I have error handling middleware, it actually takes 4 objects, and that's how Express knows that it's error handling middleware. And what that means is that, let's say I just made something just to see called unknown. So slash unknown. And what do I want to do in that case? Well, in that case, I want to immediately jump to my error because I know that that's bad. And so I say next, and maybe I'll give it an object with like status, and I'll say 404 or like 403, just to see. And it doesn't matter if this is like at the very top or something. It would see this, it would skip anything in between because I'm actually putting something in the next, and then it would jump down to here, and the error object it got would be this error object provided. So let's try this. When I try and get slash unknown, I'm going to jump down to my error handling middleware, and inside my error handling middleware, I'll say something like console.error. Console.error error. Maybe I'll include something in there like message deno. So maybe I'll say something like console.error error.message, and that's going to print out on the server. But I still might want to communicate with I want to communicate with whoever sent this request. So I'll say res.send nothing. And there's actually a special case for that where I could say res.send status, and then I'm going to say, well, what status? In this case, error.status, and that completes my error handling middleware. So let's see that happen. What we're hoping is that we try and get unknown, and because we call next with this object inside of it, it skips all the other middleware. It doesn't even check. It won't even log it, and it will just jump down here and execute this middleware. So let's see that. slash articles slash unknown. Console.error is not a function. They are right. Error. Let's try that one more time. All right, so what happened here? So first off, it didn't print any information about it because it skipped all those levels. It skipped the logging middleware. And then I print deno here because that's what I wanted to print when I got an error. And then I sent back a 403. And this is the useful thing about these status codes. I sent back a 403, but Chrome knows enough to simply write forbidden because that's what 403 is supposed to mean, and it's giving some information to my user. If I look in network, I could see that it's a 403, and this will put things that are errors in red, and that's the reason why you should send a status even in the case of an error. Yeah. Yes. How is Chrome reading which file? Right, so what did we actually send back to Chrome? Well, let's see if I can open this up. Open in sources panel. So that's the whole thing, huh? Well, what it sent back was a HTML. Like, what happened here is that when I matched on this case, I said res.sendStatus 403, and what Express did is it created an HTTP response. It gave it a status of 403, and it gave it a body with nothing, I believe, or I'm not sure whether it was Chrome or Express that wrote the word forbidden here. But it just created an HTTP request like any other and sent it back. And that's always going to be the final stage of whatever request you get in your Express app. And in fact, if you don't send a response, that is an error. Like Express will send out a 404 eventually on a timeout, but you're supposed to respond even when something fails, because that's the point of these status codes, that you are still communicating information about what happened. Okay, so we're going to get started on the workshop now. The workshop is going to walk through all of this pretty much step by step, but we will be here and we have basically all of today and tomorrow, so woohoo. And you have 5 minutes of a break, and I'm going to Slack out pairs. Yeah, we got another question? We got one more question. In what situation would one write middleware? Okay, so let's say there was some, you'll see it in the workshop, but you might have middleware that says, well, if there's anything in the body, what I want you to do, so here's some middleware that you're going to write in a bit, where I say something like app.use/, so this matches for everything. And what do I want you to do here? Well, I want you to do res.body. So I want you to create this thing called body that's on the response object. And I want you to make it equal to, like, I don't know, let's say anything that was off, I'm coming up with, well, let's say I use this feature. So we already had our get articles, but what if I had something like app.useArticles? Well, that's going to match anything that starts with articles. And I'm also going to include something like this ID, and I could access that by saying like, so I'm saying like I want this body object, and that is going to have this thing on it called ID, and ID is actually rec.params.id. And so now if I made a request to /articles/1, what that means is that I'm adding something to the body that has that ID. Maybe I'll add something else where I'll say like, so let's say I'm using it to look it up. I'll say article equals, well, I have that articles object, so I want to get the index of that article. And so what that means is that by the time I get to /articles, that actually won't match. Instead, I'll want to do something like this, app.get /articles/ID, and this colon just means wildcard, as in like it matches anything because what I expect that to be is, you know, a number maybe. So it'll be 1, 2. And then here, by the time I'm here now, what I could say is res.send. And what do I want to send? I want to send just that article. So normally I would have to look it up, but I did that in a middleware step. So I said if something starts with articles and has this ID thing, well, I added something to the body. So I can say send res.body.article. And it's really about either when you want to do something every time, or when you want to say like, well, when you go down the /users route, there's some work I want you to do that you're going to do for anything in the /users route. And first do that work, and then when we get to some later stage, we're going to use what we did there. So a common thing you might have is like authentication middleware. So I might log to say, what is this request? And before I do my routing, I say, okay, I want to authenticate that this person is who they say they are. I do some middleware that matches everything to say, you know, authenticate that this person is actually logged in. And once I authenticate that, I'll call next, and that will move to my next step of middleware. If I can't authenticate that, I'll say next with an error and send in an object saying we couldn't authenticate you, and then we went down a different path. And so it's saying like, it's really twofold. It gives you the choice of calling next, which is also the choice of just jumping to the error handler if that's what you want to do. But it also gives you the choice of like doing some work that then a bunch of other things will use. So like this app.use/articles works for anything that matches this, and it will work for this app.get here, but it will also work for some sort of like app.put, or it'll work for, you know, app.get/article/id/summary or something. So anything that matches that middleware is guaranteed to have this thing on its body called article. And it's just a way of like doing some work that you know a specific set of endpoints are going to want to do, and you don't want to do that work repeatedly for each of them. All right, so giving you a small break now, I'm going to slack out pairs, and we'll start the workshop, and we'll be here.